In this video, we'll be exploring the purpose and architecture of the CPU. A CPU, or Central Processing Unit, is the brains of a computer which sits on a motherboard. It's responsible for executing instructions and processing the data that the computer is given. It does this by following the Fetch-Decode-Execute Cycle, which can sometimes be referred to as the Fetch-Execute Cycle. Like the name suggests, the CPU follows 3 steps to turn code stored in memory into actual instructions. Firstly, the code fetches any instructions and data that it needs to process from memory. It then decodes these instructions so that it knows exactly what it needs to do before it enters the execute step, where these instructions are acted upon. This can be fetching more data from memory, or performing a calculation, or storing data back into memory. If we take a look at the major components in the CPU, we can see the arithmetic logic unit, control unit, registers and cache, which are all responsible for helping the CPU perform the Fetch-Decode-Execute cycle we mentioned earlier. The ALU is responsible for performing arithmetic and logical operations, such as adding or subtracting numbers. The control unit coordinates the CPU and is responsible for decoding the instructions that the CPU gets and working out what to do with them. The cache is responsible for storing frequently requested data or instructions inside the CPU rather than in memory, so that instructions can be executed much more quickly. Registers, like cache, are very fast storage, but they're designed for specific purposes, so they can't be written to with random pieces of data or instructions like the cache can. The CPU doesn't just work alone though. It's also connected to input devices such as a keyboard and mouse, and also output devices such as a monitor or speakers. It's also connected to main memory, which stores all of the program instructions and data within it. Main memory can store much more data than the cache within the CPU can, but because it's further away from the CPU, it can take much longer to get the information back. The von Neumann Architecture is a model for computers that's been around since 1945 and is still a good baseline of how computers work today. It describes a system where both programs and instructions are stored in memory, which is called the stored program concept. The architecture consists of all of the components that we were talking about earlier, but includes 4 specific registers: the accumulator, program counter, memory address register, and memory data register. The accumulator holds the results of any calculations that have been performed on the ALU before the data has been written to memory. The program counter holds the address of the next instruction to be executed. The memory address register holds the address of where the data should be fetched from or stored to. And the memory data register holds the data that has been read from or will be stored into memory. So let's recap what we've covered in this lesson. The CPU is the brains of the computer. It works by following the Fetch-Decode-Execute cycle, which involves firstly fetching instructions and data from memory, then decoding these instructions to work out what the CPU should be doing, before executing these instructions. We've also covered that the CPU consists of an arithmetic logic unit for performing calculations, a control unit for deciding how the CPU should execute an instruction, some caching for providing fast access to frequently used data and instructions, and registers for storing specific pieces of information relative to the running of the CPU. These registers include the program counter, accumulator, memory address register, and memory data register. So that's the end of this video. If you'd like to test your knowledge and access other lesson resources, then make sure you head over to revisio.uk.